Hi, in this lecture you are going to be looking at an example for k-means clustering with Python. The data set that is given for this exercise is again cars. It's about some technical details about cars like the horsepower, the RPM, miles per gallon on the highway, miles per gallon on the regular roads, and the price. And using this data, we are going to cluster or group these cars into four logical groups as the algorithm might give us. And we're going to see how we can do k-means clustering using Python. We start off with loading a bunch of these libraries here and then setting the operating system directory to the clustering directory. So we first load the data. The auto data is loaded from the file called autodata.csv, which is again available as a part of your resource bundle. Let's look at the data that is there as a part of this data set. So you have things like make, fuel type, aspiration, doors, body, drive, cylinders, HP, RPM, miles per gallon city, miles per gallon highway, and the price. For this clustering example, we are only going to be focusing on the numeric features in there. We can also use the other features if we can convert them into equivalent numeric features. In this case, we are just going to focus on these 5 attributes for clustering purposes. Let us first start doing some plotting to see how the plots look like. We start off by plotting the horsepower against the price. And you see that when you plot horsepower against the price, okay, you kind of see a little line there, an ascending line, but not that close. It's a really spread out line. And then you can also do another thing, which is miles per gallon for city against miles per gallon for highway. And let us look at that graph, and this is how that graph is going to look like. So you see that this particular graph, the miles per gallon and for city and highway closely track with each other. As one increases, you see the other one also going up. So there is a very high correlation between these miles per gallon, and that again is kind of expected given if you know about how cars work. One of the most important things you want to remember about clustering is that it uses distance measures. If it is using distance measures, it is important that all the features are of the same scale. So what we would be doing here is we would be doing some pre-processing of the data to convert all the data to be of the same scale. So this is the original data that we had, where you see that the highway HP is from a range of like 69, 68 kind of. RPM is from in the thousands. Miles per gallon is about 31, 47, etc. And price is again in a different range. Now we are going to scale all these 5 features such that they all come down to kind of the same range of values. And that we do by using the preprocessing.scale function, the scale function that is available within scikit-learn. So you first convert these values into float and then pass it to the scale function and then reassign them back to the same column names. You take a column like HP, convert it into a float, and do a pre-processing of scale and assign it back. And let us see how that particular thing works. And finally, we describe the columns. Now you see that the columns have changed in terms of the range is all pretty much looking the same. So horsepower is now a range between minus 1.48 to 4.21. RPM again, which used to be in the thousands, is again in the range of minus 2.0 to 3.0. So all of these have come back now to the same range, and this is a good candidate now for using for other clustering purposes. Moving on, we are going to be now starting to do the clustering process. In a clustering process, there is no splitting of training and testing data. We just trying to group the data into logical groups. So we import the k-means library function from sklearn, and then you create this model's k-means, and you have to tell it upfront how many number of clusters you want. So we're saying we're going to do 4 clusters. So we're going to first start with 4 clusters. The data that we are going to be using first for clustering is only 2 columns, HP and price. That is because we want to just use two-dimensional data for clustering so that we can easily plot that on a graph and see how the clustering has actually happened. So we're just choosing two columns, HP and price, and we're only going to be looking at the first 100 rows. So first 100 rows and two columns, HP and price, and we again call model.fit in order to do the k-means clustering. Now the model is built, and there is no prediction per se in this case. We're just going to call it once again for prediction. We're just going to call the prediction function, and then the actual clusters that are predicted for each of the card types is available in this prediction variable. There are 4 clusters, it's numbers between 0, 1, 2, and 3. In order to see how the clusters look like, what we're going to be doing is we're going to be plotting these variables, HP and price, which were the input to the clustering, on a scatter plot, and we're going to color the scatter plot by the actual predicted value. So each cluster will get colored differently when we plot HP versus price using this command. So you see that we do auto data, and then we see color equal to prediction, so it is going to be colored by the actual prediction, actual cluster. So you see this is the cluster that it has come out with HP versus price, and you see there are 4 distinct colors there. There is the first cluster here in blue, the second cluster here in yellow, the third cluster in here is almost like dark red, and the fourth cluster is like here in cyan. So these are the 4 clusters, and each point corresponds to individual rows in the data set that was presented. So these are the 4 clusters that are formed. We only did clustering here with 2 dimensions, HP and price, and only for 100 rows. Now let's try to extend the clustering with a more amount of data and see how that one works. So we're going to now extend the clustering to like 5 numeric columns. Like we're going to call everything from HP to price. You see that there's a change here. It is not a comma, it is a colon. So it is all the columns from HP to price are being included here. And then we're going to be building the model again, and then we are trying to predict again. So this is like the prediction for all included, all the things, all the rows and all the columns. Only thing, it is not easy for you to now plot this on a 2-dimensional plot because there are multiple dimensions here. This is how clustering works. Pretty simple and straightforward. This can be used to group data into logical groups, like groups of customers or groups of geographical points and stuff like that. Now, how do you decide on the total number of clusters that particular data set has? How many logical clusters the data set has, and that is, you find the only way for you to find out is to try clustering by 1 cluster, 2 cluster, 3 cluster, 4 cluster, and you try to measure something called as the withiness or distortion between these clusters, and you then try to plot them, the distortion values against the k values. And then wherever there is what is called the elbow that it takes, and when an elbow happens, the elbow point is where it tells you that is the optimal number of clusters that is happening for this particular data set. So we're going to be doing that. Now we're going to be doing clustering here. We're going to do that from a range of 1 to 10. We're going to build 1 to 10 clusters, and then we're going to see where we get the knee actually. So for each of the clusters k, we're going to be building the model. And then for each of the model, we're going to be computing what is called as the mean distortion, which is like a formula that you would see here, a deep formula that you can explore in detail when you actually look at it. We just kind of take these clusters and actually going to compute the distances, individual distances between each of the points, and then trying to figure out the mean distortion. Once you do that, let's try to now plot the mean distortion on a plot. And what you would see here is this graph. Now you have the number of clusters on the x-axis and the average distortion on the y-axis. What you would notice is that there is a slight knee that is happening here. It comes down here and slowly takes a knee. Sometimes it will be like this, and this almost like an L-shaped knee. In this case, there is a slight knee. That slight knee is happening around 3. That kind of tells you there are 3 unique clusters in this data set. Depending upon the data set, sometimes the knee is pretty sharp, sometimes the knee is not very sharp. In this case, the knee is not very sharp. But that kind of tells you the optimal number of clusters that are sitting in this specific data set. So this is how you do clustering with scikit-learn and Python.